You may be wondering what's going on. The format is different. Well, occasionally I'm not quite sure what happens, but sometimes I can't pre-process the movie that I filmed. When I download it from the recorder to my laptop, and then I use Microsoft's Movie Maker to pre-process it. Sometimes, if I'm doing other tasks at the same time, I find Movie Maker is rather fragile, which is annoying. A lot of people complain about the lack of robustness of Microsoft's products, and I find that too. A lot of their products crash a lot. It's annoying. So, just a few times the past 5 months that I've been doing all this deGarisMPC filming, I've had this. I think it's the second or third time that I've had to refilm. Just give the whole lecture again, because I just couldn't get any other option to work. So now you may find some little bit of stuff here on the left, which is sort of from where this is at, is several days, day or two ahead. So just ignore it. Now, so I have to, in a sense, from my memory, go back a day or two. So it'll be somewhat disjointed, but you need the continuity. Of course, you don't want to have a gap, a hole in the lecture with missing content. So now I might be, I've zoomed in a little, so you're effectively just getting this. So my head may go out of the picture. It doesn't matter too much. So we're talking about the three cases. Remember, we're getting the PDA, the machine, to behave like a grammar, a context-free grammar, a CFG. And we're talking about the transition rules for the machine that's to behave like a grammar. And there were three cases, if you remember. When the top of the stack contains a variable, that was case A, and then case B is when the top of the stack contains a terminal, and case C, where well, that corresponds to the empty stack. That corresponds to when the top of the stack is the $. And so we're constructing the machine so that it behaves like a grammar. So what will the transition rules of this machine be, say, in these three cases? Now, in the first case, the top of the stack is a variable, right? So that means that you will then pop that variable and then push the right-hand side of a rule in the grammar. So here'd be a rule in the grammar. So here's the variable that's at the top of the stack, okay? And here's the right-hand side. Typically, the right-hand side will consist of a string, an intermediate string of terminals and variables, okay? So to get the PDA, machine, to behave like a grammar, you'll pop this variable that's at the top of the stack, and then you'll push this right-hand side. You push this string W onto the stack. Okay, so you want a transition rule for your machine that does that. Okay, well here it is. Now in state Q loop, right? Well, just a quick reminder. What are these three parameters, if you like? What do they mean again? The first one, this ordered triple. That's the current state. This is the symbol that you're currently reading on the input string of your machine, your PDA. In this case it's epsilon, so that means ignore, do nothing, just ignore the input string. Okay. And the third one is the symbol that's at the top of your stack. Okay. In this case it's A, it's a terminal. Sorry, it's a variable. Okay, A, it's a variable, capital letter. Variables have capital letters, terminals have small letters. Okay, So in other words, you're in case A, you're seeing a variable at the top of the stack. So what do? Now this is delta. It's a transition function from one state to another. It's transition functions are for PDAs. Okay. So you stay in this. And these two. So this transition functions delivers a set of ordered pairs, and these ordered pairs are what? The next state. Well, actually, you stay in the same state, so you stay in Q loop. Comma, and the second maybe it should be here. And the second member of the ordered pair, that's the string, the symbol that you push onto the stack. So we will push this string, this right-hand side of this grammar rule. Okay, so that's causing the machine, the PDA, to behave like a grammar. That's the whole point. Okay, so we take this right-hand side and we push it onto the stack. All right. Now, what do we do in the case of case B, where the top of your stack is now a terminal? Well, you want your machine to behave like a grammar, right? So if it's seeing a terminal at the top of its stack, that terminal is generated by the grammar. But you want the grammar to behave like the PDA. And what's the PDA doing? Well, it's reading an input string and going from state to state, depending on the current state and the current symbol being read in the input string. Okay? So if you want these two, if you want the grammar and the PDA to behave the same, they have to describe the same string. Like the PDA has to accept the string and the grammar has to generate the same string. Okay? So when you see a terminal, say here, let's say the terminal symbol is little a. Well, you want the corresponding symbol in your input string to be the same symbol, right? You want you're trying to your grammar's trying to generate a string, and that string should be the same as the string being read in by the PDA. Okay, because the whole point of the exercise is to get the PDA behaving in the same way as a grammar. The PDA is simulating a grammar, behaving like a grammar. Okay, so you want the input string of the PDA to be the same as the string generated by the grammar. Okay, that's what you're aiming for. So when you have a terminal at the top of the stack, that terminal symbol should be the same symbol that's been currently read in the input string by the machine, by the PDA, right? So when you're in, so again the same triple, right? The current state, the current symbol being read in the string, input string in your machine, and this is the current symbol at the top of the stack, or the symbol at the top of the stack. Now you want these two to be equal, right? So when that happens, well, effectively do nothing. Just stay in the same state, and then you've got an epsilon here. That means do nothing with the stack. You just ignore the stack. Don't push or pop or do nothing. Don't push anything under the stack. So that's an epsilon here, right? But the critical thing is these two are the same, and that's what you want. Now, if you had a different, let's see. So there's a difference between these two. Well, there's no rule for it. So that branch. Remember, you're talking about a non-deterministic PDA. So that branch in your tree, the development of state after state, and with all its branching, whenever you get non-determinism. Well, if these two are different, that since there's no rule for when they're different, that branch will die. Okay, and so if each time you get a terminal at the top of your stack, that terminal is the same symbol as the corresponding symbol currently being read in the machine. If that keeps happening, then that's fine, that's what you want. And eventually you get to case 3, where the top of the stack is your $sign, and that means success. That means that the string generated by the grammar and the string that's input at the the input string of the machine, the PDA, those two are the same. So that's a success. And so well, it's the next session. Well, I can read it out. What case 3 would be, what the transition rule is for there. Now in case 3 you're detecting a $sign. Okay, so you'll have a $sign here, and there's no, you've read through all your string. So in the machine, so you'll have here an epsilon. So you don't, in fact, you don't care about, you don't bother reading the string anymore because it'll be empty. So you have an epsilon here. That's still Q loop. That'll be $sign. And here you'll now change your state. It'll go to Q accept and epsilon, because you're not going to push anything onto the stack. So you just ignore the stack. This will be Q. This will become for state, the third case. This will become Q accept. All right. So right. So it's probably, you may be a bit confused here. This does happen occasionally. I just, for some weird reason, Microsoft's Movie Maker software fouls up when, well, I'm becoming increasingly suspicious when I multitask, when I do more than one thing. When it's pre-processing and I'm doing something else, because I think the software is fragile. It's happened several times now, so it's pissy.